Welcome back to the part 2 of CKS Killershell Solutions 2024. Welcome to this channel Tech, Life and Fun. Please do hit like and subscribe. That will give us motivation to make more informative free content like this for you. All right, over to question number 7. This question talks about open policy agent and gatekeeper installed on the cluster. And they say that OPA is basically blacklisting what registries can be used for downloading your Docker images. And the ask is to update so that verybadregistry.com is also blacklisted. And then it talks about test it by creating a pod using this image from this blacklisted, to be blacklisted image repository, and then see that it doesn't get created. So let's go to the context and let's see what OPA constraints are available. So basically these are CRDs, custom resource definitions, that are used by OPA. So we see that there are two constraints, and the one that looks relevant to us is blacklist images. So let's see what this pod trusted images thing is. Let's just say kubectl get blacklist images, pod trusted images. So we see there's not a lot here, just applying to type of pod, and so not a lot we can do here. So what we'll do is we will look into blacklist images in particular. So let's see kubectl edit constraint templates. This needs to be constraint templates and then blacklist images. So this is our constraint template, and we see these lines here. Talks about which registries to whitelist, to blacklist rather. So let's create one more entry here. And the registry we can take from here. All right, yeah, that's about it. And then we can test it by creating a pod in the default namespace. So let's just say, give it any name. There you go. Gatekeeper has rejected it, not a trusted image. All right, we are good with question number 7. Let's go to question number 8. It talks about Kubernetes dashboard is installed in this namespace, Kubernetes dashboard, and it has few security issues. So we have been asked to deny the skip login, deny insecure access, add auto-generate certificate argument, enforce token authentication, and then it should be only cluster level access. So when it says allow only cluster internal access, it is most probably talking about the service. So it's most likely that the service that is exposing Kubernetes dashboard is a type node port service. We need to change it to cluster IP. So let's get cracking on this one. Let's jump to the namespace in question. All right, kubectl get deployments. Here it is Kubernetes dashboard. So let's try to edit it. Kubectl edit deploy. So there you go. Quite few arguments that we need to change. So the first one is deny user to skip login. So enable skip login. Let's escape DD, delete this line. Second is deny insecure access. So let's delete this line as well. Third is add auto-generate certificate argument. So let's do that. And then, all right, the last part on the deployment is to change the authentication mode to token. So Kubernetes dashboard supports two type of authentication modes. One is token and one is basic. Basic is for ABAC and token is for RBAC. So we are converting it to RBAC here. Successfully edited. Now let's take a look at these services. Yeah, it's node port. So let's change it. Let's remove the node port and let's change the node port to cluster IP. Yeah, that's about it. We're done with question number 8. Let's clear everything out. Question number 9 talks about app armor profile present at this location, and we are supposed to install it on this particular node and then add a label to the node as well, and then create a deployment pointing to this particular node via a node selector and also with the app armor profile loaded. So let's first create this app armor profile. Let's just see the name of the profile first. Very secure is the name. It's present on the terminal. We need to take it inside cluster node where app armor is supposed to be up and running, and that's where we will load this profile. So the command for that is scp cluster node :/root. Let's keep it on the root. And let's copy the file name as well. We missed that. Yeah, not the node name, sorry. scp file to the root location of the cluster node. scp is done, and now let's ssh into the node. There it is, profile is present. Let's load it via AppArmor. Let's confirm that it is present now. Name of the profile should show up. That is very secure. We'll grab on it and yep, it's loaded. Now we need to create a deployment. So let's come back to the main terminal. Before that, we need to label this node as well so that this deployment lands on that particular node. So command for that would be kubectl label node name and the label. Cool. Now we will create deployment. Kubectl create deploy. Name is app armor. We are in the default namespace, and these things we will update in the YAML itself. So we'll use our export, which is minus dry run equal to client minus o YAML, and extract it into a file. Let's say Q9 for question 9. We missed minus image. Let's give the Nginx image given in the question. Yeah, Q9. Looks like our export is not properly set. So let's actually do one thing. Yeah, we missed setting the export in our main file. So let's do that. Export. All right, first let's give the node selector. Comes at the pod level. Node selector as per the label. This needs to be a colon inside a YAML. And next we need to give annotation at the metadata level. So let's create space for that. And then maybe let's save it and come out, and we need the documentation for this one. So we search for AppArmor and then open the AppArmor documentation, and then go down for the example of how to give the annotation. Yeah, this particular piece, let's copy all of it. Let's paste it, and let's fix the indentation. And also the name of the container is C1, so let's change that as well. And then the name of the profile, which is very secure. Cool. We have done the node selector, and then updated the container name as well as given the annotation for loading the AppArmor. Just to be sure that the name we have given is correct. Yeah, very secure. Let's create this deployment. We can see that pod is not coming up, and it says that, okay, capture the log. So let's see. Kubectl get pod. Let's just see the logs. Permission denied, no files found. So probably our AppArmor is doing its bit. So let's capture these logs here. Okay, we are done with this question. Let's move on. Next question talks about Team Turtle wants to run some of their workloads more secure way. So they are talking about creating a new runtime class. And they say that runsc is working on this particular worker node. So we need to create a runtime class and then create a pod using that runtime class and making sure that this pod lands up on this particular node. Yeah, that's a bit. And then once it's running, we need to capture the D MESG logs, which will show that gvisor is in place. So let's quickly create a runtime class. For this, again, you need to look at Git documentation. Yeah, let's copy this YAML. So name would be gvisor and handler would be runsc. Okay, runtime class is created. Now let's try to create the pod. It talks about a namespace. So let's first switch to that namespace, Team Turtle. The name of the pod is gvisor test. Nginx image. Let's do dry run client and export it into a YAML. Let's call it 100. Q10 we already did, so now Q100 for quick reference, and then here we can update the pod. So under the spec of the pod, you need to give two things now. One is runtime class name, which is gvisor, and the other thing is the node name, which is cluster1 node 2. All right, let's create this one. Yep, gvisor test pod is running and it's running on cluster1 node 2. Great. Last part, let's capture the D message logs here. So the way to do it is kubectl exec -it and it will be gvisor test. And then you give it as a command. There you go, starting gvisor. So yeah, it's working fine. Let's capture the logs in the output file as per the question. All good with question number 10. Let's return to default namespace and clear out the terminal. Let's move to question number 11. Let's move to the namespace. Two parts of the problem. We need to first, the second part is pretty straightforward. We need to read the secret value and base64 decode and store it in this file. And the first part is the trickier one, where we need to read the secret directly from etcd using etcd command and then store the value there. So let's first do the second part, which is more easier and straightforward. The value. All right. Now to run the etcd command, we need to actually run the etcdcl command, and that would be under the control plane node. So let's create one more terminal. Let's SSH into the control plane. And for the command, you can search this on care documentation, encrypt etcd. Now, if you come down, so this is the command. So let's copy it. Just create a temp file and store it there, and then we will update it. Actually, let's not create it here. Let's create it on the main terminal. I'll tell you shortly why we are creating this thing. So the thing is, you need to provide the etcd certificates here, which will pull out from the control plane node. Let's first clean the values coming from the copy paste. Let's correct the namespace. It's not default, it's team green. And then the secret name. We'll supply these values. Let's go back to the control plane node, and the way to do it is we say cat etc slash kubernetes slash manifest slash kube API server grep etcd. So these are the values. So let's copy them one by one. Maybe let's just copy it together to save some time and paste it there. So CA file. Mhm. Certificate. And then the key. So with this, our command is ready. Let's just see if it runs fine. And we'll need to run it inside the control plane node. There you go. And we need to save it in this file. Again, this file would be kept on the terminal and not inside the cluster control plane node. So we go back to the terminal, we open the file. Sorry, this one. I hope we have not messed up anything here. That's fine. So vi and then simply paste this encrypted value coming from etcdctl command. If you need to understand more like what this encrypted value is coming, just read this page in detail and you will understand what's really going on here. Encrypting confidential data at rest. Oh, sorry. Okay, so we are done with question number 11. Before moving to question 12, let's clean out our terminals. Okay, so this question is that in this namespace, in this context, there are restrictions and you cannot, there are 3 secrets, but you cannot read their content directly. So you need to find a way of some kind of a security breach to somehow read the secret values and store them in respective files. So let's see what's going on here. Let's switch to the namespace. Let's see the secrets. See, we cannot even list the secrets. Let's see what all we can list here. We can only list the pods. So let's do one thing. Let's look inside the pod. Maybe we will find something interesting there. kubectl cat pod 1 minus o YAML. So if we see here, secret 1, as mentioned here, there are 3 secrets, secret 1, 2, 3. So secret 1, we can see is mounted as a volume. What is the mount path? etc secret volume. So maybe what we can do is exec into the pod and then look into etc secret volume. Just for reference. And then what we can do is exec into the pod. And then go to the mount location. So there we have the value UR. So let's take this value, come out of pod 1, and let's put it into this file. So we have the first secrets value. Let's see the second pod, if we can find the second secret. So we see the second secret is mounted as an environment variable. So secret 2 is mounted. So we need the value of this environment variable, password. All right. So let's exec into the pod. And then do an env and search for the password key. Sorry, you need to grab password. Env, no, okay, env needs to be small. That's not how you list the environment variables. So it needs to be in small caps. Yeah, there you go. Password equal to and amazing. So we have the value. Now let's look at into the third pod if you find anything. We don't find any secret mounted as such, but we do see a service account mounted here. So maybe this service account has access to secrets. Let's just give it a shot. Again, let's exec into this third pod. Let's try to curl to Kubernetes URL and see if we can fetch the secret. So let's first capture the token. Let's just verify if we have the token right. And yes, we do have cat token. All right. Now let's try to make a curl command. HTTPS Kubernetes.default / API / v1. Let's just see if we are getting a URL correct. Yes. And now let's go to namespaces / namespaces is restricted. And then go to secrets. Yes, I think we are getting there. Secrets and then the secret name. There you have the value. It's base64 decoded. There you have the third value. So let's come out and let's just put it into the third file and be done with this question. Cool. We are done with question number 12. With this, we'll stop this particular section this particular part of the Killershell solution series, and I'll see you in the next video.